Fukushima Unit memes. Prompt criticality explosion. Assertion someone made along with something sane and rational. It is possible to obtain a prompt criticality nuclear reaction in a nuclear power plant in the event of a meltdown. That's actually true. A prompt criticality scenario is the uncontrolled nuclear fission reaction. That's correct. And an explosion. No. This is something people won't let go of, so let's get this done. If it was that easy to make a nuclear bomb or an atom bomb go off at all as an initiating explosion, you would just put two half-critical masses together and let them expand and detonate instead of using explosives and extremely precise design. They don't do that because they don't. Remaking this assertion because people want to believe it, usually it's because of Fukushima, doesn't make it really true. But anyway, let's discuss the actual explosive forces involved. The largest thermonuclear warhead on record is Starbomba, and 50 megatons out of 100 it could have been set for. It was a Dila-yield bomb. Krakatoa was a 200 megaton explosion from a volcano that the heat caused a steam explosion. That's a steam explosion over 4 times more powerful than a nuclear bomb. Now, I want to repeat that. Steam explosions can, in this case, a naturally occurring one, be more powerful than a nuclear bomb. And yes, there are occurrences where radioactive deposits like uranium have effectively refined themselves into something that acts almost like a nuclear power plant, and they don't blow up. Because they don't. This assertion that can be done this way would imply that, oh, all you have to do is just put the materials together and they'll go off. That's not really true. It's not a binary explosive where you mix situation with material and it explodes. So let's start with this basic stuff here. Steam explosion is not a nuclear fission reaction. Explosion. No criticality accidents, prompt or otherwise, have ever resulted in a nuclear-based explosion. The term explosion does not refer to a nuclear explosion. Nuclear detonation requires a mass far beyond critical of weapons-grade fissionable materials under extremely demanding conditions and pressure and uniformity, not from the control rods out of or the radioactive material in a nuclear power plant. Nuclear weapons are actually very delicate pieces of machinery, and a nuclear detonation process is very complex and timed. If you can blow up the missile carrying a nuke with conventional explosives or just break it with an impactor and the detonation doesn't go off, that means that it's safe to shoot it down with shoot down a nuclear missile. That also means that it's not accidentally going to go off. This is something someone agreed to, but they decided that nuclear criticality could cause an explosion. None of them do. There are no occurrences like that. There was an unconfirmed speculation, not with criticality accident experts, about Fukushima suffering a criticality accident, and based on incomplete information about the 2011 Fukushima nuclear accident. A Dr. Frenek, I can't pronounce his name, speculated that transient criticalities may have occurred. He didn't say that that was what initiated it. And it could have been, but it doesn't explode. It just means that it's gone hot, it's now boiling water. The explosions are usually from steam. Uncontrolled chain reactions might occur at Fukushima, and obviously do. Same thing with Chernobyl and all the others. The only exception to this thing is fires, where the uranium mixes with something else and starts combusting. These produce really bad accidents, and that's where you get fallout from, but they're not an explosion caused by the materials just sitting next to each other or bringing in close proximity. You can take 50 or 100 critical masses and put them together into a container and make them spherical so that they have the highest likelihood of doing something wrong, and they still won't blow up. Because they don't. This isn't a discussion. That's just how it is. And I'm going to read a story from someone. This is actually the person's assertion about what happened to him. The blue flash was clearly visible in the room, although the room, was well illuminated from the windows and possibly the overhead lights. Total duration of the flash could not have been more than a few tenths of a second. He reacted very quickly and flipped the tamper piece off. The time was about 3 p.m., May 21st, 1946. When he turned around, he saw a flash of blue light and felt a wave of heat on his face. Subsequent calculations put the total number of fission reactions at about 3 quadrillion, 1 million times smaller than the first atomic bomb, but still enough to send out a significant burst of radioactivity. His left hand, initially numb and tingling, became increasingly painful. This was the hand that had been closest to the demon core. The scientists later estimated that he had received more than 15,000 rem of low-energy X-rays. His whole body dose was around 2,100 rem of neutrons and gamma rays and X-rays. 500 rems is fatal. He died 9 days later after the accident in a coma at the age of 35. That core was eventually used to make an atomic warhead for a test. There is no incidence where that is an example of a criticality experiment that went bad and it did not explode. And that was under ideal conditions to cause an explosion. And I'm going to repeat again, the Fukushima, name that unit, prompt criticality explosion did not happen because it's not physically possible. Steam explosions, fires, material, heck, lead burning could cause an explosion at this point because everything goes completely to hell in those conditions. But the laws of physics don't break down just because you have a political bent or because you saw the story on the net. Thanks for watching. Have a good day. Good luck with that.